What if you could stop time, just for 1 second? Imagine the entire universe, every planet, star, and atom frozen in a single instant. But not you. You're still moving, a lone consciousness in a silent, static cosmos. What would you do? Well, the truth is, you wouldn't do anything at all. In that frozen reality, the first thing that would happen is you'd be plunged into absolute, terrifying darkness. In this video, we're exploring the scientific paradoxes of stopping time, and why this ultimate fantasy is actually a journey into the breakdown of reality itself. The power to stop time is a classic fantasy. We've all seen it in movies and comics. The hero freezes the world to dodge a bullet, or a villain pauses everything to pull off the perfect crime. In those stories, the user is like a ghost, moving freely through a world of statues. It's a thrilling idea. It's also not how reality works, not even close. From a physics perspective, the ability to stop time isn't a superpower, it's a prison, more absolute than anything you can imagine. To see why this ultimate freedom is really the ultimate trap, we have to start with a bigger question. What even is time? It turns out it's a lot more than just the ticking of a clock. So let's unpack this thought experiment. We'll need to set aside our pop culture ideas and look at the cold, hard laws of physics. Because when we do, we find that a world without time is a world without, well, pretty much everything. It's a trip that starts with losing your senses and quickly escalates into paradoxes that threaten the very logic of the universe. Before we can talk about stopping time, we have to agree on what we're stopping. For most of history, people thought of time as this universal constant, a cosmic clock that ticked the same for everyone, everywhere. But then along came a patent clerk named Albert Einstein, who completely changed our understanding. With his theory of relativity, Einstein showed that time isn't some separate thing. Instead, it's woven together with the 3 dimensions of space to create a 4-dimensional fabric called space-time. Think of space-time like a giant, stretchy sheet. Heavy things, like planets and stars, create dips and curves in it. That curvature is what we feel as gravity. But the mind-bending part is that this warping of space also warps time. According to Einstein, time is relative. How fast it passes depends on how fast you're moving and how strong the gravity is around you. This isn't just a theory, it's a measurable fact called time dilation. Clocks on GPS satellites, where Earth's gravity is slightly weaker, actually tick a tiny bit faster than clocks down here on the ground. Astronauts on the International Space Station zipping around the Earth at high speeds age just a fraction of a second slower than we do. For an observer with mass, their own personal time never stops. The closest you could get is by approaching the speed of light, where your time would slow dramatically relative to someone else. Only light itself, which has no mass, experiences no passage of time at all. There's one other concept that gives time its direction: entropy. This is the basic principle that things in the universe tend to move from order to disorder. A hot coffee always gets cold, a sandcastle always crumbles. This steady march toward chaos is what gives time its forward arrow. So when we talk about stopping time, we're not just pausing a watch, we're attempting to halt a fundamental dimension of reality that allows for change, motion, and life. And that's where the problems begin.
Okay, let's do it. Let's hit the cosmic pause button. The universe is frozen for 1 second, but you're not. What happens first? The answer is nothing. A profound and absolute nothing. First, your world goes black. Instantly and completely. Sight works because particles of light, photons, travel from a source, bounce off things, and hit your eyes. Your brain processes these photons into an image. But if time is frozen, every single photon in the universe is stopped in its tracks. The light from your lamp, the sun, your phone, it's all locked in place. No new light can travel to your retinas. You'd be in a darkness deeper than any cave. At the same moment, you'd be hit with total silence. Sound isn't a thing on its own, it's a vibration moving through a medium, like air. These waves of vibrating molecules travel to your eardrums, which your brain then interprets as sound. If time stops, all that molecular motion stops. The air molecules carrying the sound of traffic or a conversation would freeze mid-vibration. You'd be instantly deaf. So in the first moment of your 1-second time stop, you are blind and deaf, floating in a lightless, silent void. But this is just the beginning. The real nightmare is about to start because the very air around you has just become your tomb. So you're floating in a silent, black void. Your first instinct is probably to panic, maybe wave your arms or take a breath. You can try, it won't work. You are no longer surrounded by gas, you are encased in a solid. Air is made of molecules zipping around at incredible speeds. We move through it so easily, we barely notice it's there. But if time is stopped, that motion ceases. Every air molecule is frozen solid, locked into a rigid structure. The air has effectively become an invisible, immovable wall. To move your arm, you'd have to shove trillions upon trillions of frozen nitrogen and oxygen molecules out of your way. But they can't move. Trying to push against them would be like punching a diamond wall that extends across the universe. You would be held in place by the very atmosphere that you were just breathing. And that brings us to the most immediate problem. You can't breathe. Breathing is mechanical. Your diaphragm moves, creating a low-pressure area in your lungs, and air molecules rush in. But now there's no rushing in. The oxygen molecules just outside your lips are static. You could expand your chest, but no air would enter. You'd be trying to inhale a solid. You would start to suffocate, blind, deaf, and completely paralyzed. This is the grim reality of this particular thought experiment. It's not a superpower, it's a death sentence delivered in several ways at once. Okay, that was bleak. So let's try to cheat the way science fiction often does. Let's imagine that when you stop time, you project a small time bubble around yourself where time keeps flowing. Inside this bubble, air molecules move, light bounces, and you can breathe. Problem solved? Not really. We've just swapped one set of impossible problems for another. First, the edge of your bubble is now the strangest place in the universe. Inside, atoms are moving normally. Outside, they're frozen solid. That boundary would be an absolute, impenetrable wall. You could walk right up to the edge of your bubble, but you couldn't go any further. Trying to stick your hand through it would be like trying to push through the fabric of reality itself. You would be free to move, but only inside your tiny, invisible cage. Then there's the air. You can breathe, which is good, but you're breathing a finite supply of air inside a sealed bubble. Once you use up the oxygen, you'll start inhaling the carbon dioxide you just breathed out. With no ventilation, the air in your bubble would eventually become toxic. And what about sight? You could see anything inside your bubble, but looking out would be strange. Since no new photons from the outside world can enter your bubble, you would only see the world based on the light that was already inside the bubble at the exact moment time stopped. You'd be trapped in a snow globe, looking out at a perfectly preserved but unreachable world. The bubble doesn't give you freedom, it just gives you a slightly bigger prison.
So far, we've stuck to the immediate physical consequences, but now we have to dig into the fundamental laws of energy, and this is where things get even weirder. Let's talk about heat. At its core, heat is the motion of atoms. The faster they move, the hotter it is. If you stop all atomic motion outside your bubble, you have, by definition, created a state that resembles absolute zero, the coldest possible temperature. This creates a massive conceptual problem for the law of conservation of energy, which says energy can't be created or destroyed. All of the heat in the universe, from stars, from planets, from the Big Bang itself, where did it go? For this scenario to work, it would have to just vanish, which violates one of the most fundamental rules of physics. Now let's look inside your bubble. As a living human, your body generates heat through metabolism. Normally, that heat radiates away into your surroundings. But now, you're surrounded by a universe that is effectively at absolute zero. The heat you produce would be trapped inside the bubble with you. It would have nowhere to go. Now, the idea that you'd instantly cook is an exaggeration.
Over just 1 second, the heat your body produces, about 100 joules, would barely raise the temperature of the air around you. But if you were frozen in time for longer, that trapped heat would eventually become a very serious problem. We've explored the biological and physical problems, and they're all dead ends. But the ultimate paradox is that this whole scenario is fundamentally incompatible with Einstein's theory of relativity. The foundation of modern physics is the constancy of the speed of light. No matter how you're moving, the speed of light in a vacuum is always the same for every observer. Our scenario, where you are moving through time but the rest of the universe isn't, completely clashes with this. From your perspective, time flows normally, but if you looked at a photon just outside your bubble, its speed would be 0. You've created a situation where the speed of light is both its normal value and 0. Physics simply can't reconcile that. This leads to an even bigger breakdown: causality, the idea that a cause must happen before its effect. Let's say your heart beats once inside your bubble. For you, a cause, a nerve signal, led to an effect, a muscle contraction.
But for the universe outside, 0 time has passed. When time restarts, reality would have to accept 2 contradictory facts. Your heart is in a different state than it was an instant ago, but no time has passed for it to have changed. An effect has occurred without a cause in the universe's timeline. What would happen to the fundamental forces, like gravity and electromagnetism, if the particles that carry them suddenly stopped moving? The truth is, the question itself is unanswerable because the scenario requires us to throw out the rulebook of physics. So, what if time stopped for 1 second? The heroic fantasy quickly dissolves into a scientific nightmare. You wouldn't be a master of the universe, you'd be its only victim, trapped in a dark, silent, and solid prison of frozen air. Even with a sci-fi protective bubble, you're just in a slightly larger cage, slowly running out of air and cooking in your own trapped body heat. At the most fundamental level, the act of stopping time is so incompatible with the laws of physics that it breaks the concepts of energy, light, and causality. The steady forward march of time can sometimes feel like a limitation, but it's not a prison. The flow of time is the very thing that makes existence possible. It's the framework that allows for motion, for change, for light, and for life. Stopping it, even for a single second, would be stopping everything that matters. If you learned something new or found this topic as fascinating as we do, don't forget to like the video, subscribe to the channel, and hit the notification bell so you never miss a moment of space discovery. Until next time, keep looking up. The universe is full of surprises.